So let's say you don't have any production data, but you would like to run some sensitivities for a given fluid system or something along those lines in Whitson Plus. You can actually go ahead and do that after you've defined your fluid in the numerical model part of Whitson Plus. Since you don't have any production data, which you see here, obviously there's been no production data uploaded, the only option that you actually have to run this is on a synthetic BHP control, okay, because you don't have oil, gas, water, or any historical bottom pressures uploaded. So what the synthetic bottom pressure will provide you with is a decline from the initial reservoir pressure, which in this case is 8,000 psi, and we'll reduce that down to 1,000, and that will happen over 450 days, and from there on out, you will have a constant bottom pressure until day 1,000. Okay, so if I wanted to do this, I set up the parameters that I'd like to have. Let's say I want to change some of my rel perm parameters. Maybe I like to do something like this. I set up whatever case I'd like to run. We see that this will be a multi-phase case because we'll go below the saturation pressure of 363 days. From a geometrical perspective, I'd like to have, at least in this case, no volume bound frac tip, and maybe I like to increase my matrix permeability a little bit, and then click save, and then just make sure that I run this for 1,000 days. So the nice thing that you'll see now is that we'll get some simulated rates out for all the phases: oil, gas, water. You see that the GOR is increasing, the water cut is also changing over time. We see also that of course, our bottom pressure is following this decrease from 8,000 down to 1,000 at 450 days, and from there on out, it's constant. But let's say I want to use these rates in another feature in the software. Let's say I wanted to take these simulated rates and test my multi-phase flow material balance method, for instance. To do that, it's very simple to pretend that these rates are actual historical rates in the software, such that I can run the Analytical RGA, the Numerical RGA, etc., etc. So the way to go ahead and do that is just to go to Export up here to the right, and then you just click Set Historical Data equal to Simulated Data. And what will happen in the software is that it just takes the simulated data and it will then overwrite the existing production data that you have for this particular one. And at this point, you might have to just do a quick refresh to make sure that all the plots are updated appropriately. The nice thing now is that you can go, for instance, into the flow material balance, and you can take that for a spin. So you can see, does the multi-phase flow material balance method actually work in general? So now we pretend that we have these simulated rates, and would like to see if the slope that we are observing on the plot actually resolves something close to 3.7 or so MSTB. And in this case, we see that we're getting something very close. This is probably, slightly subject to interpretation, but around 3.8 or 3.8 million barrels, which is very, very close to 3.6 that we have here input. We can also take this data in and run our analytical RGA, see how what changes as you go below the saturation pressure, for instance. Here we see that this combination of multi-phase flow effects and superposition effects causes a strange behavior around the saturation pressure, which is expected. Or we can also go ahead and run the numerical RGA, for instance, with this synthetic data. So here in this case, I changed my NRGs to be, I think it was 3, and then I had 2. Or maybe 1.5 and 2.5. But except from that, I think everything else was the same. So I can then go ahead and run the numerical RGA method, and then see if I can pick a LFP and an OIP that provides me with something representative for this well. In this case, we're looking at maybe something along these lines. That will be very, very close. You see that the LFP and OIP 3.6, that's basically what we had. And if I export this into that numerical model and just run this on gas rate control, for instance, we'll see that we'll basically get identical results, or not identical, they'll be very, very similar. Yeah, there we go. So that's an example of how you can create synthetic cases in the software and then verify the different features in the software if they work, or just for your own learning in terms of getting up to speeds on what parameters are actually affecting the well performance and whatnot.